In this video, we want to solve first problem of 2022 British Informatics Olympiad, BIO 2022. Okay. The first problem, question 1, decrypt. Each letter in the alphabet can be given a value based on its position in the alphabet, being 1 through to Z. So A being 1, A is 1, B 2, C 3, through to Z being 26. Two letters can produce a third letter by adding together their values, deducting 26 from the sum if it is greater than 26. So this part is important from here to here, and finding the letter whose value equals this result. Okay, so for example, if you have A, if we have B, if we combine them, it is 1, it is 2, so their sum is what? Their sum is 3. Now 3 is what? Is C. Okay. The simple encryption scheme for a string is as follows, working from left to right. After leaving the leftmost character alone, each character is replaced with the character produced by adding it to the character to its immediate left. Okay, so for example, if we consider encrypt, if we consider E and N, so if we consider sum of them, E plus N the value, it will be S. So look, if it is less than 26, you consider that. If it is greater than 26, you should subtract 26. Then it applies S and C and reach V here. Then it applies VR, it reaches N, NY, it reaches MP, it reaches C, and CW, it reaches CT reaches W. Okay, so the strategy is this. Part A, this problem, 24 marks, write a program that reads in an encrypted string between 1 and 10 uppercase letters inclusive and outputs the original version of that string. So let me explain first for you. This is the code, and let me explain how we can find the code. Let me move it below bottom. Okay, so let's see. For example, we know that A, B reaches C. Okay, so it is 1, it is 2, it is 3. Okay, now, so for example, suppose we have AB. If we apply it here, we have AC. And C is what? C is A plus B, 1 plus 2. So I want to see, if I see A and C, I know previous one is A. I want to find this. Let's see what happens. In this case, you say, okay, C is 3, it is 1. So this one is what? Is subtraction of C minus A. Okay, so here you see A here. If C is here, you say, okay, like 1, for example, 3. You say that this letter, when it wants to go here, it needs from 1 to 3. We need 2. Okay, so if you have, for example, consider it is x1, x2. We want, it is x1. We want to know this letter is what? Okay, so we know x1 plus this one reaches x2. You consider it is x3, for example. Now, if x1 is less than x2, if x1, the value I mean, is less than or equal x2, less than x2, so x3 equal to x2 minus x1, like here, c minus a. But sometimes otherwise, x2 is less than or equal, else, let's write else, x2 is smaller than x1. So it means this. So it means x1 goes someplace, and then we will reach this. So it means that x1 plus x3 minus 26 is x2. So we consider it is x3 in this case equal to x2 minus x1 plus 26. And if I want to show you here, look, minus c minus a, for example, plus a, this negative 1 plus 1 because of 0 based. So here you say c minus a plus this one Here you say C plus 26 minus A, exactly like here, plus 26. So for coding, I say, okay, for example, if I want to explain completely my code, you say, okay, let's take the string S. Here you say, okay, for I0 to I less than length, we place SI to PSI, then we define this decryption, and how we work on that from last word. From last word, you consider, okay, C is the last one, for example here, C is this one, A is previous one, and you want to reach what reaches here, so you want to find this. So it says PSI, it shows I minus 1, the index. So this one, you say, okay, if C is greater than A, it is C minus A plus this one minus 1. And in this case, PSI is C plus 26 minus A plus big A. The value of that minus 1. So it is the code. And the reason is only this. The whole reason that calls to type that code, the algorithm is this x1 less than x2, x3 is x2 minus x1, else x3 is x2 minus x1 plus 26. Okay. You can check this code, and if you type this input, then you get this as an output. Okay, if you had question about this or had question about other parts, you can send message to my WhatsApp number in the description comments. Okay, let's solve part B. It says give a 5-letter string whose encrypted version matches the original. So here, if you consider Z, 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 5 Z's. So the first one is Z, the second one is Z plus Z. Z plus Z is what? 26 plus 26 is 52. The problem, from assumption of the problem, it says you should subtract 26, it will be 26 against Z. So it will be Z. Similarly, the next one, Z, Z, Z. Okay, so problem 1, part B. This part doesn't need any code. Let's solve part C. Part C says how many times must you encrypt Olympiad before it becomes the original string? Again, so I typed the code and I said, okay, for example, take T, and that it says how many times you want to decrypt or encrypt here, but the name of file I've named it decrypt, and each time it checks that is it same with the original one or not. If it is same with the original one, means with Olympiad, it says it is good and says in which step, and I starts from 0 to, I've checked to 1000. So in I0 it checks in 103, it is good I. In 100, so 0 it checks, 1 it checks, 102, so 1 time, 2 times, 102 times, and 103 times. And in this part, as you can see, after 104 times, we reach Olympiad. And again, as you can see, from 103 to 207, again 104 times, because again, in 104 to 207, number of times, it will be 104 again. Okay, so we will see the answer is 104. As you can see, each 104 times, we will reach Olympiad again. For this problem, for this part, you should type the code like this. If you had question how I've typed the code, or wanted to learn more things, want to know the solution of other problems, as I said, feel free to send message to my WhatsApp number in the description comments. Now let me explain problem number 1, part D. It says how many three-letter strings if encrypted 999. How many nines are there? 1, 2, 3, 4, 12 nines times become the original string again. Okay, so for this problem, let me explain. I said consider first I've used 3 4s here, and I've used long int for 12 nines. I said for int I0 to 26. I is the first letter, the value of first letter. JK. Okay. For each of them, then I've created a string in NS. Then I've applied as much as I can to reach the first one again. Okay, and I said, okay, number plus plus in each case to see do we reach the same answer, the initial string or not. When I reach the initial string, and here I see that, okay, they are same. So I said x was what? 12 nines. The remainder when divided by DOR, DOR is the number of times the cycle you reach the first one. For example, if you start with ZZZ, the length of cycle is 1. Okay, so we call it DOR, this variable. It says if x divided by DOR is 0, number plus number is the number of strings that satisfy the equation. At the end, see out the numbers. And if you see out the number, it will be what? It will be 4394, the answer of this problem. How many strings? And I've written some of them. For example, BBA, the length is 13, BBB 13, these one ZZA, ZZB to ZZZ. The lengths are 1, they are divisors of 12 nines. Okay, so problem number 1, part D is this. I've typed the code. If you had question about this problem or other problems in BIO or USA CO for America, if you had problem about this, or BIO first round, second round, or other exams, prestigious exam informatics, feel free to send message to my WhatsApp number in the description and comments. And please don't forget to subscribe, turn on the bell, and like the video. Thanks. Bye.